Hello, and welcome back to section 16. In this video, we'll be going over example 2. This problem here is an example of a problem that cannot be solved using substitution. So we can't find I particular using substitution. Instead, we'll have to use an integration method to find the particular response. So I'll show you what that looks like. So we have this function. And again, we're going to assume that this right-hand side takes the form AE to the SBT. By the way, if you had a constant function, so say it was just 500, well then we could say that it's 500 e to the 0t, and therefore SP would be equal to 0. So if you try to do one of the group problems, just note that. That's what you would get there. So anyway, in our case here, SP is negative 10. So let's try to do substitution. I can already tell you it's not going to work, but let's see what it looks like when it doesn't work, so that when you run into it, you know what happened. So di dt plus 10i equal to 500e negative 10t. So this is already in the AE to the SPT form. We're going to say that ddt is equal to S particular, which in this case is negative 10. So again, it's this number right here. So when I do that substitution, I will get negative 10. Again, we're going to call this I particular instead of just I. Plus 10 I particular equal to the right-hand side, which is 500e to negative 10t. So when you go and do that, you should see immediately what's going to happen. We're going to get a 0 or a 0 I particular either way. We're going to get 0 I particular equal to 500 e to the negative 10t. And this will never happen. So if I divide this by 0, well, that's divided by 0. And if I just say it's equal to 0, well, there's no time t that makes this equal to 0. So this is what it'll look like. You're going to get something where you're going to try to divide by 0, and it's not going to work. So is there any way we could know ahead of time that we can't use substitution? And there is. So remember that SP was negative 10. If we go back to our differential equation and we try to find S1, so di dt, so again this is for the natural response, plus 10i. So when you find the natural response, you set the right-hand side equal to 0. So we're going to find our I natural in this case. So we're going to sub in. We're going to say that ddt is equal to S1. And we'll try to find that. And you're going to find that S1 times in plus 10 in equals 0. We divide that out. We find that that S1 is equal to negative 10. Do you notice that this and this are equal to one another? So that is what happens when S1 is equal to S particular. When they are the same rate, we run into a problem. We can no longer do the substitution shortcut. By the way, if you don't want to do this full method, you can just look at the differential equation and note that it is this number right here. That is S1. S1. So it's basically the generic form of dx dt minus S1 equal to the right-hand side. Sorry, S1x. There we go, S1x. So it's already buried in there. You don't actually have to do this full thing. You can find it. So I'll do that from now on. Okay. So now we need to do what's called, we need to use an integral to actually find this. So this is going to look a little weird. So I'm going to flip over to the back side of the page here so we can work through our integral. So I'm going to rewrite our differential equation. That is d dt I plus 10i equal to 500e to the negative 10t. And so how the integration works is the generic form is we write I particular is equal to e to the s1 t integral e to the negative s1 t g of t. And if you remember, g of t is the right hand side. So this is g of t and dt. And we just go from 0 to t on our bounds. So let's plug in our numbers. So we're going to get e to the negative 10t integral from 0 to t e. So we get a negative 10, so we get a positive 10t. And then g of t is 500 e to the negative 10t dt. So we don't really worry about the left-hand side too much. We work inside the integral. So when I combine these, so exponentials so when I multiply these two exponentials by each other, we're basically going to add their exponents. So we're going to get 10t minus 10t. We're going to get e raised to the 0 power. So I'll show that step. E negative 10t integral t to 0. We're going to get 500. We're going to get e plus 10t minus 10t dt. And so that becomes e to the 0, which is a 1. And so we get e negative 10t integral t to 0 times 500. And again, if you could go e to the 0 if you wanted, but I'm going to go ahead and not. I'm going to skip that part. And so yes, you could move the 500 out, but you still need to put a 1 in here. So when we integrate this, we're going to just get 500t. So we get e to the negative 10t, and I suppose if you did it, you'd get 500t, and your balance would be from t to 0, and so you're just going to get a t in there anyway. E to the negative 10t times 500t, and then when you rewrite it, you generally put the 500t in front. So 500t e to the negative 10t. So that is I particular. Oops, you couldn't see those last couple steps. I'm sorry about that. So again, t to 0, so the 0 will go away, the t, and then, alright. So it basically, whenever S1 and SP match, you're going to get this extra t that shows up in your particular response. Alright, if you have any questions, feel free to contact me.